Hello everyone, welcome to our tutorial on properties of circles. And I believe those of you who are in Sec 3 Express and Sec 4 and A, this is what you are covering for this year. Okay, so let's get on with the properties. The first one, what you see on the board is an angle at the center AOB and another angle at the circumference ACB. Let me label them. So you have this angle AOB and angle ACB, and the characteristics of these angles are such that as mentioned, one is at the circumference and one is at the center, and they both have the same arc. Okay, so angle AOB has this arc AB, while the angle ACB also has the same arc, which is AB. Okay, and if you look at their position of the angle, they are both facing in the same direction, which is facing this way and facing this way. They're facing downwards, okay? Or rather, they're facing in the same direction. It doesn't matter downwards or leftwards or whatsoever, they are facing the same direction. And because, or if you have this situation, then you can say that if the angle at the circumference is theta, then angle at the center is equals to 2 times of the angles at the circumference. Okay, meaning if the angle ACB is equals to 40 degrees, then this one will be 80 degrees. Okay, or if this angle here is equals to 100 degrees, therefore this one must be 50 degrees. So the condition is that they must both have the same arc AB, and one must be at the center, one must be at the circumference. Then you can observe this law. Okay, let me show you one more thing. Is that another way to find this angle is by tracing their starting and the ending point. Okay, so now look at the green line. Okay, I'm going to show you the green line. For angle AOB, the starting is at A, goes to the center, and then ends at point B. Okay, so trace the green line again. So from A, from the same point, from A also I go to the circumference and then end at the same point B. So because both angles start and end at the same point, then this law can be observed. Okay, but make sure they're both facing the same direction. All right, let's look at the other figure. Okay, you can also observe the same property in this case. So previously we have this angle is theta, right? So this angle is theta, and then this angle at center here is equals to 2 theta. What about angle ADB? Okay, let's look at angle ADB. Is it the half of angle at the center? So let's check using the same property, the same way that I told you just now. So angle ADB starts at A, goes to the circumference, then ends at the point B. Okay, let's try for angle AOB. It starts at A, goes to the center, then ends at point B. So because they have the same starting and ending point and both face the same direction, then we can simply say this angle is also theta, just half of the angle at the center. Okay, let's look at the third diagram. So this time around, we have another angle, AEB. So previously we have this angle, which is 2 theta. This one is theta. This one is also theta. And so angle AEB, so again we can try, starts at A, goes to E as circumference, ends at point B. And by now you can guess, you can see that they both have the same starting and ending point. Therefore, this angle is also theta, half of the angle at the center. Okay, so or you can look at it the way around, because the angle AEB is theta, so the angle at the center must be double of it. Okay, so what do we call this property? We call it simply angles at the center is 2 times angle at the circumference. So these are the 3 examples that we have gone through just now, and so this is our first property of circles that you need to know. Okay, so catch you at the next videos for the rest of the properties.